So we left off talking about discrete variables and continuous variables. So we'll write the definition down. I'll do my best to explain with examples. And by the way, I have the chat on the side, but also if you see a mistake, you can just let me know. Definitely want to catch them as soon as possible. So a discrete variable is a variable that can take on values that change by small increments. Let's see. Only change by minimum increments. Sometimes I think of it as like set that's the data for that variable is countable. And we'll do examples here, but when we get to continuous, those values are infinite. These are countable if the other one's infinite. Okay, let x be a variable. X can be any value in the set 1, 2, 3, 4. Okay, so this is a number line for your values of x. X can be 1, 2, 3, or 4. We'll represent each of those values with a dot. So here, or here, or here. Okay, so this is a discrete variable. Okay, as a side note, I may put questions about being discrete or continuous on your homework, but I don't like to put this stuff on the test. We'll kind of test on other ideas instead. But we do want to understand as best as we can the difference between discrete and continuous. So some new variable, we'll call it z. Z is any value in the set we're going to start with 0 and then go to 0.5, 1, 1.52, and continue to do that. 0, 1, 0, 5, 1, 1.5, 2, 2.5. variable is z, we're going to put a dot at each of the values of z, at least the first few, and start with 0. 0.5. So it's implied that this is an infinite set. It keeps on going towards positive infinity, but your values of your variable change by small measurements. And another way I think about these discrete, the graph for a discrete variable is when you draw them, you have to pick up your pencil to draw the next value, and you have to pick up your pencil to draw a different value. And with continuous graphs, you don't pick up your pencil at all. It's just, well, let's do that next. So continuous. Oh, by the way, z is discrete. Continuous variable is a variable that can take on infinitely many values on an interval. Let's see. Continuous variable is a variable that can take on, I like that part. A variable that can be any, infinitely. I'm going to call this variable w. So let w be a variable. Okay, such that w is any value in the set. Okay, so this set is your values of w. This bar means such that w is less than 7. Okay, so I don't know if we'll need, like, this can be written as an interval, and I don't know if we will go over interval notation or not. We'll see. We'll see if it's necessary. But this set goes from negative infinity up to 7. Does not include 7. Okay, here's your graph, and we're going to mark 7. Don't include 7. It's a strict inequality right here. And all numbers less than 7. Okay, so I would probably give you maybe all of this information and then ask discrete or continuous if I did put a question like this on your homework. When you draw this graph, you start at 7 and you continue going over to the left. You don't have to pick up your pencil. This one's continuous. One more of these. So your variable, let's just call it x. Let x be a variable. Such that x is any value in the set so your set starts and then your x values such that 2 is less than x and x is less than or equal to 3. 2 less than x less than or equal to 3 equals the set. Okay. So with strict inequalities, you don't include 2, which means there's a soft bracket. And then you go to your number 3, include that number with a hard bracket. This is called interval notation. I don't think we're going to need this. It's just for the example. Let's go on and draw a graph. You've got x values. 2, 3. Don't include 2. Or don't include 2. This equal signs means include 3. And all the numbers in between. So when you draw that graph, you can start at 2, not including 2, but then go straight over to 3 and then stop the graph. This is a continuous variable. Okay, so we've introduced variables and they can be qualitative or quantitative. Quantitative variables are discrete or continuous. And now we want to start organizing values of your variables. So we need to do what first? Frequency distribution. So okay, frequency is the number of occurrences of a repeating event. And a frequency distribution is a table that lists values of a variable with its frequencies. So frequency distribution. So your table has, let's see, values of the variable and frequencies for the values. And I'm just going to put frequencies. So I put some steps to make a frequency distribution. Okay. List values of the variable. And then you're going to have a place in the middle to do a tally. Tally number of occurrences. And at the end, you get the total to have your frequency. So count tallies to get frequency. Okay. So we'll start the instructions for your example here, and then we'll do all the scratch work afterwards. So construct a frequency distribution for the following data. Okay, so I'm going to keep my data organized in a little table over here, and then we'll do our frequency distribution as a table below. That has places for, it's 3 places, one for your category, one for the tally, and one for frequency. Okay. It doesn't need to be perfect. Let's just do like A, B, C, A, B, C. B, C, A. So, table is called frequency distribution. Okay, so this side is a category. In the middle, you take tally. On the end is a frequency. The possible values are A, B, and C. And then just, does that say this? Oh, thanks for the comment. So check with me, may make mistakes, but there's 1, 2, 3, 4, 5. 6, 7. All right, so I got 7 for A. B occurs once, twice, 3 times. I got 5 for B. C, 1, 2, 3. And then you're done. New problem, we have construct a frequency distribution for the data. New table, new data values. Okay, values of your variable are 0 or 1. So we're just going to put 0s and 1s in here, starting with 1, 2, 3, 4, 5, 1. So 5 zeros and a 1. Let's do 0, 1, 1, 0, 0, 0. Let's put in a whole row of zeros. Just 0, 0, 0, 0. Man, let's just put 1 here and put some more zeros. Okay, your new frequency distribution is a table. The category goes on this far side, tally in the middle, and on the other side is frequency. Possible values are 0 and 1. Count your zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wait. I got 20. 5, 10, 15, 20. So you guys get 20? Double checked it. I think we're good. Tallies for 1 should be better. There's 1, 2, 3, 4 of these guys. And that's it. So let's do relative frequency. Okay, is the proportion or percent of observations within a category. proportion or percent of observations within a category. Okay, when you get your relative frequency, you just take the frequency and then divide by the total number of occurrences. Cool. So let's do a relative frequency distribution. Is a frequency distribution like this one, just an extra spot at the end for relative frequencies. So again, is a frequency distribution that also lists relative frequencies. Okay. Bit steps. So the first step is to create a frequency distribution. I'll probably ask you to construct a frequency distribution. Number 2 is find the total number of frequencies. After you get the total number of frequencies, compute each relative frequency. Alrighty, here's some data. Actually, first we'll say, use the following data to construct a relative frequency distribution. Construct. Alrighty, so the data looks like this. I have alpha, beta, beta, alpha, beta. And then a row of beta. This over. And then beta, 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 alpha, beta. First step is to make a table like we were doing, a frequency distribution table, and we'll have relative frequency at the end. Okay, so category first. Tally. Get your frequency. And then now we have relative frequency. Alpha or beta are your possible values. Tally for alpha, there's 1, 2, 3. Tally for beta, and also check with me that I don't make a mistake. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Got 12. Let's check it. You need to get the total number of frequencies, so let's do that right here. 15. So here's 3 over 15, and this will be 12 over 15. And then you're done. So the answer is this table. This is like scratch work, but I'm still going to leave it here just because. One more. This time, instead of having data, someone's already organized all the values, and you just have to take this frequency distribution and turn it into a relative frequency distribution by putting this extra column. So this will say complete. No. It's kind of a word problem. Just a little bit of story to it, really. So pet owners were sampled. And asked how many cats they have. The results are in the following data type, put the following table. But we could be more specific. It's in the results are in the frequency distribution. So I'm going to put extra space here what you have, what you're given is just a category. We can skip the tally part. Next is frequency. So this is the table you have, and then we're going to add this extra place for relative frequency. Because I'm going to ask. I'm going to ask you to construct a relative frequency or complete the relative frequency distribution. Cool. So we went from 0 cats to 5 cats. 0, 1, 2, 3. And then from this sample, there were 7 people who had 0 cats. And 5, 5, 3, 3, 2. So it's our goal to finish this table. You get your total number of frequencies. Okay, 10, and then that's 17, 18, 19, 20, 23, 24, 25 total. So here's 7 over 25, 5 over 25, 5 over 25. Put each frequency over the total number of occurrences. Okay, 3 over 25, 2 over 25. And that would be correct, but just for adding to this problem, I did put in what all these decimal numbers are. So 7/25 was 0.28. Five over 25 is 0.2. Got 0.2 again. 3 over 25 is 0.12. Another one of those. This one is 0.08. So we're just gonna try to ask a couple questions about this. I think that'll be enough. So first one. What percentage of pet owners have or has 3 cats? Okay, so 3 cats is here. Go over and get a proportion of 3 over 25. That's 0.12. And that's 12%. Okay. What proportion of pet owners have, let's do 3 or 5 cats? Cool. So I have this table in my notes, so hopefully you do too. I'm gonna erase it to make room to have scratch work. So for 3 cats, it was 0.12. And then add the percentage for 5 cats. 5 cats is 0.08. So 0.3. That would be 8, 9, 10. Yeah, 0.2. Is that what you got? Oh, that's 3 cats. 5 cats. I did. What percent of pet owners have 3 or more cats? So we'll do the one for 3 cats, but then also add 4, the one for 4 cats and the one for 5 cats. Write it as a percentage. Three cats is 0.12. Plus 1 for 4 cats. The same. Plus 1 that goes for 5 cats. 0.08. This time, let's see, I got 0.32. I think we're good. Should we try one more? Make something up. Yeah, we're good. Okay, at the end. I'm gonna make homework on topics we've covered so far. Stay if you have any questions or if you just want to keep, writing your notes down. But have a good day, everyone. Thank you.